We will begin 6.1b by discussing the head minus tail rule for vectors. We can use this to prove that two vectors are equivalent. The vectors given are in arrow form, so we know the initial and terminal point of each vector. The formula x sub 2 minus x sub 1, comma y sub 2 minus y sub 1 can be used to represent a vector in component form. Let's look at an example where we can use this rule. We are given 4 coordinates. We use these coordinates to make vector rs and vector pq. We'd like to know if these two vectors are the same vector. Let's use the HMT rule. We will start by using the formula to create each vector. The initial point is r, so x sub 1 is -4 and y sub 1 is 2. The terminal point is s, so x sub 2 is -1 and y sub 2 is 6. Using the formula to find vector rs, we substitute the values and simplify. Vector rs is 3, 4. Let's do the same thing to find vector pq. The initial point is p, so x sub 1 is 2 and y sub 1 is -1. The terminal point is q, so x sub 2 is 5 and y sub 2 is 3. Using the formula to find vector pq and substituting the values, we find that vector pq is also 3, 4. Therefore, vector rs and vector pq are the same vector by HML, which represents head minus tail rule. Just for a visual, let's look at the graph of vector rs and vector pq. Notice both vectors go in the same direction and have the same magnitude, so they are the same vector. Here are a few more formulas. The first formula is just to formalize what we did in example 1. X sub 2 minus x sub 1, comma y sub 2 minus y sub 1 changes a vector that's in arrow form into component form. To find magnitude or length of a vector, given a vector in arrow form, you use the same formula that you would to find the distance between 2 points. If your vector is written in component form, then you can take the first component and square it, plus the second component and square it, and square root the answer. The notation for magnitude, which is the length of the vector, is the absolute value of v. Again, absolute value for vectors stands for the length of the vector. Let's look at another example. We are given the information for the vector pq in arrow form. If we would like to rewrite vector pq in component form, we can use p for the initial point, q for the terminal point. Using our formula, substituting the values, simplifying, vector pq in component form is -2, -2. If we now want to find magnitude, and we use the coordinates P and Q, then we'll use this formula, substituting the values, simplifying, simplifying, simplifying. The square root of 8 is 2 times 2 times 2. A pair of 2's take a single 2 out, leaving us with a 2 inside. The magnitude of vector PQ is 2 root 2. Magnitude is the length of the vector. To find the magnitude of vector PQ, we could have also used this formula. We had already written vector PQ in component form. Substituting component A and substituting component B and simplifying, we would have arrived at the same answer. Let's look at a visual to make sure you understand the idea. If I graphed vector PQ, the distance from P to Q is known as the magnitude, which was a length of 2 root 2.